All right, guys, welcome to Wayne's World Garage. Thanks everybody for watching this. A couple of you guys said, hey, we want to see more about making these new head blocks for the Frick sawmill. So the head blocks are what the knees go on, and the knees go on head blocks which go on the carriage, which goes back and forth. They take a lot of abuse. So the knees are the ones which have dogs, which go down and hold the log into place. So what happens is when the knees go back and forth, because you're moving a 6,000-pound log, a lot of force is on it. So our head blocks are worn out. So I decided, well, how hard can it be to make some new head blocks? I'll just get some steel, cut some holes, and weld it up. Mr. John from Frick and Jeep warned me. He says, dude, you're getting in over your head. This is a big project. And he's right, because his friend Jeff said he made new head blocks. It took him 2 weeks working full time. I might have more than that in this already. So here's what we did. Here is a picture of an old head block. And what this does, it's upside down now. This goes on the track itself, the carriage itself. So these are 25 inches apart. Okay, and this big tube rod goes through here with a gear on it, and the gear spins. Hold on a second. I have to edit this out. Oh. This normally has this gear through here. Okay, and as the drive shaft comes through here, and as the sawyer pulls the set works back and forth, this gear moves. And when this gear moves, this gear moves. This gear moves back and forth, moving your knees. Pretty easy, huh? These guys were brilliant back then. So what I ended up doing was, there is a nice diagram on the Frick website, or not the Frick website, on the open interweb here, and it has some dimensions about how this thing is supposed to be put together. Although it doesn't have all the dimensions, that's for doggone sure. So what I did is I drew up, as well as I could, some pictures with measurements of what we have here for the head block. Now, notice this in here, 46 inches. It's supposed to be 46 and a half, but what I did is I reverse engineered this old one, which was cut off so the saw wouldn't hit it. So we'll probably make the next ones 46 and a half inches. But anyway, it's important because this takes a lot of effort to do this. So the head block is consistent of 3/8 inch angle iron. It's almost 5 inches here, 1.5 inches here. If you look in here real closely, this is machined. It's a machined slot. And that machined slot is what the gear sets in. So if you look at this gear, you can see where that gear goes in, and the gear goes like this in that slot, and this one goes on top to pull things back and forth. It's all pretty well thought out, although it's heavy. On top of this here, we've got a little piece here, which I haven't made yet. We've got some round pieces here.
Where?
And we've got another round piece here, and another one of these pieces here. So, piece here, here, round pieces, right here. Does this look a little bit familiar? Check this out. So this goes right in here. So we machined this, drilled holes in it, and that's ready to go. What I did here is I modified this just a little bit because they just used some 5/8 round in here. I didn't have any 5/8 round, I had 1 inch round, so I cut it in a lathe. So it'll go like this, and it'll actually help stabilize things. So this is what the old one looks like. So the first thing I did is we got some nice steel from our buddies at L.R. Wilson, who were kind enough to give us this angle iron. And I spent a little bit of time with the nice carbide saw making these pieces. So this is my blanks. So I've got blanks made up. I've got 4 of these guys made up. And you can see, to do this, I had to take this, make this flat, and make this straight. It's doing pretty well. So now, let's go over to the milling machine. And this is where things get a little bit complicated, because right now, I had one of these I made, and I cut it out with old dimensions, but I need to make a duplicate of it. You make lots of duplicates of it. So what I want to do is put one behind the other, mark it, drill holes in the same spots. The steel weighs about 15 pounds per foot. Multiply that times almost 8 foot, it's 120 pounds. Now it's not that heavy because I cut down quite a bit of the steel, but it's still 75 or 80 pounds. And for this geezer, that's kind of heavy and hard to lift. Additionally, it's almost 4 foot long. And if you take a ruler and look at this wonderful Bridgeport mill made in Bridgeport, Connecticut, go figure, 36 inches long. So what's that tell you? That tells you I have to go back and forth and reposition the piece of metal on the mill every time I want to mill something if I want it perfectly smooth. Probably overkill, because in 1930 or 40 or 50, whenever this was built, they probably didn't do that. So let's have a quick peek here and see what we've done. Can you show down here? You see, remember that hole where I showed you where that drive shaft goes through? Okay, so I drilled that out, that's marked. These actually have 5/8 inch holes in them, but I left them as 1/4 inches just for positioning. We're gonna drill these guys out, and I've got a tap, a 5/8 by, shoot, I forget what it is, maybe 14 inch threads per inch. I'll tap these out, put them in, and weld them in. These holes here, I started using this nice hole saw. Check this out. And the teeth broke off. So a trip to Home Depot, and actually the arbor broke off too. So if anybody wants it as a souvenir, let me know, I'll give it to you. So fortunately, I could get another one from Home Depot, and that was carbide, and it cut right through it like it was butter. Kind of like it was carbide. So the next step, what are we doing here, and what is the next steps? So as I said, these pieces here have to be welded in. They actually help position things on here. So what do we need to do with this? If you look real carefully, there's a slot up here, and there's another slot down here, and I'm duplicating it. So I've got one slot done. So all I want to do is make the other slot just like this slot. So I will take this in here and I'll machine it. Now just so you can get excited and see how excited I am about this, these pins, normally they drill a hole, they probably stick a piece of rebar and weld it, but this is going to help hold this thing perfectly still, and it gets welded in here after you grind off the zinc on it, because the zinc is not a good thing to breathe. So real quick and easy, the machining part of this and welding part is probably 20% of the effort. The rest of the effort, 60% of it, 70% of it is drawing it, documenting it, and making sure you get it right. Hopefully it will be right. The other 20% of it is cleaning up the mess, because every time you use a drill, every time you use a milling machine, stuff goes flying and you just can't leave it on the floor. Well, I suppose I could, but I don't want to leave it on the floor. So let me get cracking and let me drill a little bit, let me finish machining this little piece here, and then we'll be done here with this one. So this is a little bit sketchy because there's all sorts of stuff flying everywhere. And I'm running this guy at about 1500 RPM. It's a 3/8 inch carbide bit. I hope you can hear it. You see that meter moving? Oh, no, let me flip.
Yes.
It is moving, okay. 3/8 inch carbide bit. You probably won't be able to hear it now. And this is not enough critical, but what I'll do is I'll come down here, put this in there. there's one more slot cut. Now, you can take a look. I don't know if you can get the camera on this other side. This is like beautiful, okay? And I wanted these as parallel as possible. That's exactly what we have there, so that is nice. What you don't see, and it takes some effort to do, is, go ahead and back the camera up a little bit, is when you're doing this, this piece of metal has got to be what they call trammed, basically, and it's got to be exactly the same distance all the way up from the milling head, from one end to the other end. And that takes a few minutes to do. I don't have to get it to within a thousandth of an inch, but I do want it relatively accurately because we want to do this right, and that's the way it is. So that's just a quick update on the heads. This is pretty much done now. It's the first one other than welding it up, and that's the easy part of it. I'm gonna weld it, tap these holes out, and I'll be done. But I'm not gonna do that because I'm gonna use these as models. So I will take these, clamp them up in my clamps, double check my measurements, and start making a couple new ones then. And then we'll be done. So thanks so much for watching. You all have a great day. And if you like this, subscribe, leave a comment. Take care. Thank you. Lights out.